before we get into the Angular compiler and AoT, let me tell you a little bit about myself. So my name is Uri. I'm a Google developer expert, which means I go around the world and speak in conferences, make new friends from the awesome Angular community. And today we are going to talk about AoT, but I also do IoT, robotics, electronics. You can see one example here. This is a game that I created with Angular 2. This game actually works both on the web, so there is a web version of the game here, which you can play online. That's too complicated for me. I'm going to fail now. So yeah, this is the Simon game, and this is the same code running on physical hardware. If you want to know how I did this, you can just Google ng2 Simon, and there is a blog post explaining how I got the same Angular code to run in the browser and in this physical game. And the best thing, you will be able to play it outside during the lunch break, and there will be some awesome prizes. So if you know, there is the offline dyno from Google Chrome, and I got a few stickers and magnets of the offline dyno. So if you make a good score in the ng Simon, you will get a dyno. Thank you. So apart from that, I also do stuff with web Bluetooth. As you can see, it a little bit spoiled the surprise. This is a robot that I built. You can control it from a web page. It's called Purple Eye. But if you want to learn more about it, come to my future talks. And some fun facts about me. So I dance salsa. I also play the Peruvian pan flute. And as Elad told you before, when I was a child, I played a lot of computer games, and I always wondered, how did they make the sound effects of those games? So finally, I got a Peruvian pan flute, and I can show you how they do it. Let me show you. And as Elad said, I work for BlackBerry. Yes, they still exist. And with that, let's speak about the Angular compiler. So we are going to start with shrink for speed, seeing how we can take the default Angular project that is created with the CLI and make it really small so we can deliver to production. Then we are going to start looking inside the bundle, seeing what the generated code looks like when we dive in. And finally, we are going to get to the gem of the talk, the compiler. So in order to save our time here, I won't create a new project. I already done it at home because we all know how much fun it is to wait for npm install. And you are going to learn about the CLI in Tracy's talk. So just imagine I ran ng-new AngularUP, and I got this nice project here. So this is a fresh project from the Angular CLI. You can see that I have very simple source code here. Let me just show you real quick what it looks like. How many of you have used the Angular CLI in the past? So for those who didn't, this is what the code looks like when you use the Angular CLI. It's a very amazing, doesn't work because I forgot the colon. Yeah, that's what you do with Angular 2. You create Google. So yeah. This very amazing boilerplate page. Yeah, I will share it with the CLI team that you love this page so much. And the first thing we are going to do with it, we are going to actually build it for production. So it's super simple with the CLI. We just type ng build. I hope I'm not doing any spoilers for Tracy's talk. It takes a few moments, some time to reflect about why we chose Angular. And while it's building, I'm going to tell you what we are going to do next. So we are going to run a web server on the dist directory and see what the generate code looks like. So we are going to run the web server and open localhost with some random number. And you can see this is essentially the same app, but now it's bundled in a production way. Let's have a look at the Chrome developer tools to see how big this app is. So this is the network tab. And if we just refresh the page, we can find that the upload pretty quick, 700 milliseconds. But this is localhost, come on. It's not a real thing. Let's try to emulate a regular 3G connection, which is what we get most of the time. Even if we use 4G, most of the time we don't get a full speed. So let's refresh the page, and suddenly it loads and loads and loads and loads. And it took more than 5, I don't know if you can see it, but it says 5.25 seconds. It took more than 5 seconds for the page to load, and that just to see the app works. Pretty impressive, isn't it? So let's look into the dist folder and see why the app is so big. So I'm going to open the dist folder, and we can see that we have a couple files there. We have this main bundle.js file, and if we look into it, we can actually see that it has a lot of code. And can you notice something about this code? Like it has a lot of comment. And do you have any idea how we can make it smaller? Minification, yeah, right. Or, as we like to say in the Grunt plugin way, we are going to uglify it. So fortunately, we don't have to work too hard for that, because there is a flag for that. We are going to rebuild the project and just add -prod. And with that, we are going to have a minified version of the code eventually. So as we build it, I will run the web server again, and we'll see if we manage to shrink the bundle and how much improvement we got on the loading time. 21, it's like the installation for Windows 98. It's stuck on 21 for like an hour. And it is ready. Let's rerun the web server. And so in the previous iteration, we have 5.25 seconds. I'm going to refresh now, and hopefully this compressed size of 300 kilobytes will shrink a little. Ready, set, go. So how is the race going? Not bad. We managed to improve to 2.7 seconds. So we cut half of the time by just doing the obvious thing, uglifying. And you can see that the bundle is actually a little smaller now, 182 kilobytes, if you can't read it because it's small. And can we do better? Let's look again inside this dist folder and open the bundle file. So this is the bundle file. It's much smaller, and no, I don't want to keep it. And if we look inside, we see a bunch of minified code. So apart from removing all the copyright Google Inc. comments, thank you, Google, for bloating my bundle, there is actually an open issue in the CLI for that. They are going to fix it soon. We can't really say why is the bundle big. Fortunately, there is a tool for that. It's called Source Map Explorer. And if you are not familiar with this Source Map Explorer, I wish they gave it a shorter name. It just shows you what's in the bundle. So we are going to check out the bundle. Yeah, that's a good idea. So we are going to check out the bundle with the source map explorer. Apparently, there is even a tool to hold the mic when I speak. So yeah, so this is the source map explorer. It shows me what's in the bundle. And you can see there is a lot of stuff here. In order to make it easier for you, I will just highlight one part. And I will do it by simply adding a style, background red, so you can see it more easily. So do you see this guy? It takes up much of the space of our bundle. It's about 50% of the entire bundle size. And it says here, compiler. So before we learn what the compiler is, let's learn how to get rid of it so we can get a smaller bundle. So in order to do that, I'm actually going to run the build process again, this time give it a flag called AoT. What is AoT, do you ask? Ahead of time, thank you. I knew I should have invited you here, thank you. And it's going to build again, and as soon as it builds, we are going to refresh and hopefully get under 2 seconds. And remember, it's not localhost, it's 2 seconds with the simulated speed of the actual time it will take to load on a mobile phone. And we are ready, let's restart the web server. And how much improvement have we got? We can see that we are now 1.56 seconds. So suddenly, it starts to feel good. If we continue like exploring the bundle, we can see, or I can see at least, there is also forms and HTTP, which I don't use in this app, so I could remove them and get it even smaller. In fact, I was experimenting at home, and I got it to be under 1 second. So the thing I want you to remember here, don't be intimidated by the output generated by the tools. Look into it and see. Sometimes it's really easy, just adding a flag cuts half of the bundle size, and it really improves the load time for the user. So we have seen here like some cool trick with the source map explorer and the AoT, but why is this? What is that compiler? Why do we really need it? And the answer is this: the race for performance. This is actually a real thing. Apparently, there is a Wikipedia. There is a mascot race every year somewhere in the world. And let's look back how we did change detection in Angular 1. You probably remember that people says don't have too many watchers because it's slow. So the reason it was slow is because each time we did $watch, we actually have to, on each digest cycle, walk the entire application's component tree. And each scope had an array of watchers. So we had to walk through that array, iterate through it. And each watcher was actually a function call. So we had to call a function for each of those watchers, for each of the components or the scopes in the app, for each of the change detection digest iterations. And sometimes you have several digests in a row just for moving the mouse. So that was not very effective. And then there came some smart guys came up with a new framework called React. And they decided to take a little different approach. So in React, whenever a component state changes, they actually re-render the entire component. But in order to make it efficient, they render it to a virtual DOM, not to the real document, but just to a pile of virtual objects. And then they compare it with the previous run. So they have new virtual DOM, old virtual DOM. They do some diffing to find what has been updated. And finally, they update the real DOM. Now, this is a radically different approach from what used in Angular. Angular said, let's see what changes. And whenever we figure out a change, just update the relevant part in the application. React says, let's re-render the entire application on every change, but do the rendering and diffing real quick, and then we can gain the performance. We don't need to have any kind of watchers or change detection mechanism. But there are also problems with that. So using the virtual DOM adds another layer of abstraction, which tends to slow down things. And every time we re-render, we actually create a new virtual DOM structure, and we need to discard the old one. So we need to employ many people to collect the garbage that we can generate. And that, my gentlemen and ladies, slows down the application. So what was the Angular 2 solution? The Angular 2 solution for that was really simple. Let's auto-generate super optimized code from your template. So have this magic thing that takes your template and generates some very optimized, super efficient code to create the DOM document out of those and update it when your model updates. And how do we do that? We use the compiler. So what is the compiler all about? When I first heard about the Angular compiler and actually looked in the source code, I got surprised. There is a new slide here. So before we go looking into the actual compiler, let me tell you about some advantages of actually compiling the code. So we will know better why we need a compiler. So first of all, in Angular 1, we actually use the browser to parse the templates. Now, when we use Angular build their own parser, so we get line numbers. If we have an error, we can get a message saying on line 3 in my component.html, column 54, there was actually a problem. Then we also get tooling, as we'll see in a moment. And it's also more predictable. So if we run on different browsers, we'll still get the same result, because it's not a browser parsing the HTML, it's actually Angular parsing the HTML and creating code that will create the DOM structure for the component. And another advantage that we get with that is support for case sensitivity. So with the HTML parser, it has this, I don't know why they did it, but it turns everything into uppercase, like the tag names and the attributes, so we can tell how they were originally written in the template. But since with Angular 2, we have our own parser, we can tell that it was ngIf with uppercase I, and we can tell it apart from just all being uppercase ngIf. So another advantage is that we can use camel casing for the attributes, and we no longer need those dashes inside. By the way, do you know how they call the words with the dashes inside? Kebab case, right. Or the Israeli version, shipud case. And finally, since we have code that can parse the templates and generate code out of that, we can actually run it in the server and get the same result on the server and on the client. And I think we have a talk today from Nir Kaufman about Angular Universal, which does exactly that. So I told you I will be showing you about the tooling. And one of the cool aspects of the tooling is that we are going to get autocomplete in templates, because now we have code that can actually understand the template, and it can do type checking and error checking, and at some point when they introduce the Angular language service, editors will be able to plug into that, and you will just have autocomplete in your templates based on your controllers, as you can see here. So this is coming soon. So I told you about the compiler, the advantages, why we needed it, performance, and how fun it is to just remove it from the application and shrink it by a factor of 2. How does it look from the inside? So for me, it felt like this. I want you to take a moment and reflect about all those blue balls going in the photo. So what the Angular compiler basically does I see that you are distracted by this. What the Angular compiler actually does, it simply reads our components, read the HTML files, and generate JavaScript file, a quite big one, that does the same thing as the HTML template would do. So in order to experiment with that, we are actually going to run the Angular compiler on our demo project and see what the output looks like. I hope at the beginning it will probably look like this, but I hope we'll make some sense of it. So we are going to go to our project, open the package.json, and let's add a new npm script called compile. And what it will basically do, it will call the Angular compiler and run it on the code so we can actually see the output. In the standard build process, this is done behind the scenes and you don't get to see the output. But as you can really see, it's really easy to invoke the compiler ourselves. And I'm actually going to run it, npm run compile. And in a moment, we'll be able to see what the output looks like. So yes. So that's a good question, whether we need to install NGC. And we actually don't need to install it because it's part of the CLI. It comes as a dependency of the CLI. So we just need to write this, run npm compile, and we can see the magic. So let me show you. So this is the template for the app component. Not really smart, just an h1 element with the text that we see here, with this AppWorks text. The AppWorks text comes from the controller, really simple setup. And what I'm going to show you now, I'm going to show you the code that the compiler generated for these 3-line templates. So let's just move it away so we have enough space for the generate code. And as you can see, we actually got app.component.ng factory, which is the automatically generated file with a super efficient optimized code. And it looks like this. Told you. Yeah, this is awesome. Angular, you actually managed to turn a 3-line file into a 104-line file. Amazing. So we'll just check out a few of the stuff that is going on here. So we can see that we have this create internal method. And this method actually creates the elements that are used by the template. So yeah, so we can see that it creates a render element, and somewhere in this really big line it says this is a h1, and it also creates 2 text elements, one for the title and one for the new line at the end. Very useful. We can actually see here the new line. Angular actually creates code that generates the DOM structure of our template. And as far as change detection goes, Angular actually creates this detect changes internal method, which is basically run whenever something changes in our component. We use a mechanism called zone to detect whenever something changes. So in Angular 1, we had the $digest, which ran the digest loop. Angular 2 is smarter, and it knows how to recognize this automatically using a mechanism called zone. You can Google it and learn about it. It's really fascinating what they did there. And with Angular 2, it detects the changes using zone, and then it calls detect changes internal of each of the components. And this method, apart from all the boilerplate like import for, is doing something really simple. It evaluates the expression that we gave here. You can ignore this interpolate method. All it does, it just checks that it's not null. If it's null, it's put an empty string. So we can actually read it as if it was written as concatenating these 3 strings. So we actually get to evaluate. This is the title expression. So we evaluate the expression whenever we detect that something has changed. And then we compare this current value with the previous value that we store inside the component instance. And if it changes, this check binding simply checks if the values are equal. If the values have changed, it will call setText to update the text of this element, of this H1 element. So in terms of performance, there are a lot of performance gains in the way this code is written. For example, as you can notice, we don't use any arrays, and we don't do any kind of parsing or evaluating HTML elements. We simply compare simple expressions, evaluate them, compare them, and if we detect there was a change, we go directly to the DOM and update only the specific part. Now, we also get some other nice advantages. So, for example, if I said in the template title times 2, and I ran the compiler, we could actually see that this would give us an error in the generated code. So we get free type checking out of that. Oh, I need to close the file because I modified it. So this is the file, and we can see it recompiled it, and this is the title times 2 that I had. And we actually get an error from TypeScript saying, hey, this title you have in your component, do you remember it? It is a string. You can't multiply it by 2. So we get also the advantages of checking all the codes in our template in compile time, like before we ship the application to production. So there is a lot more to explore, and I encourage you to go home and run this really simple ngc command and see what the generated code looks like. And we have a question from the only guy that asks questions here. Yeah? Okay, so that's a good question. Why do we need this .renderer, and we don't update the DOM directly? That would be more efficient. And I think you have heard that Angular is aiming to ship 10 kilobyte hello world by the end of the year. So to answer your question, the reason we use the renderer here is because the Angular team didn't have enough time to get rid of it. Eventually, the Angular compiler will improve over time, and it will probably don't call all those interpolate functions and stuff. It will generate a really simple code that will just compare and update the DOM. We are not there yet. In a few months, I hope this will happen. Now, if you want to learn more about why using a big object with which contains all the elements and the values of all the expressions that we use, like expert3, text1, is more efficient than just using arrays, I encourage you to watch the talk of Tobias Bosch from Angular Connect, where he explains how this actually compiles to a more efficient code using a feature called hidden classes, some feature of the JavaScript VM. But you don't need, the good thing is that you don't need to care about it, because the smart guys from the compiler, they do all the benchmark and they optimize and they generate the most efficient code they can on behalf of you. I think it makes a lot of sense to understand what is going on, if not, what was that? I guess it means that he agrees with us. So it's really important for us to understand in general what is going on, but the good thing is that they can change the implementation and improve it, and we can just focus on building our application and not worry about using templates and fancy stuff and having that impact our performance. I saw a question from the back, yeah? So that's a great question. I will answer it shortly. What are the performance implications on other browsers that don't have Eden classes? Actually, can we start? Oh, thank you. Actually, in a short period of time, we are going to have a new standard called WebAssembly, which will allow us to actually compile JavaScript into machine code. And I hope that those guys will pick up WebAssembly, and the compiler will also generate WebAssembly, which will be even far more optimized than this code, and will give us performance benefits across all browsers. So hopefully in the future with WebAssembly we'll get a lot of performance benefits in addition to this. And to summarize, because we are out of time, I want you to leave here with two key takeaways. First of all, Angular 2 is an amazing piece of engineering, and I really mean this. So don't fear it, explore it, just like we did. And another tool that you can take from here is this Source Map Explorer. I don't know how to pronounce it, sorry. Just know your bundles. Check out what you are shipping to production. Don't trust the tools blindly. You have seen that with just 2 flags and a lot of belief, we managed to shrink it from 5 seconds to 1.5 seconds of load time. So, thank you, and go outside to play.